This is our fourth section of probability. We're looking at two-way tables. A couple terms that I briefly mentioned, one of these and not the other. The intersection and union. This is a symbol for intersection. This is a symbol for union. Intersection is less inclusive. Union is more inclusive. For example, if I said to you, I would like all the students who play basketball and are cheerleaders. This is also the word and. Not a lot of folks would stand up because you have to be a cheerleader and you have to also play basketball. That's being pretty strict about what I'm asking for. But if I said, stand up if you are a cheerleader or a basketball player, this would include a lot more people because we're uniting the two groups. Whereas in the and situation, it's the intersection. It's what the two groups have in common. So looking at this table, let me just talk through this, then we'll look at some problems. This 20 represents the number of people who own a smartphone and an iPod. This 18 is the number of people who have a smartphone and no iPod. If you add 20 and 18 together, you get there are 38 total people that have a smartphone. Here, no smartphone and an iPod, and no smartphone, no iPod. There are 12 people total that don't have a smartphone. Total iPod owners are 28. Total no iPods are 22. The total is 50, and the total is 50 in each direction because we are counting things twice, horizontally and vertically. Let's look at some examples, see if we can figure out how to use these tables. Two-way frequency tables. How many students are in this class? Well, that's this number right here, the total number of people, 60. How many girls like to dance? So we're just looking at girls only, and we're looking at dance. This is asking for the intersection of girls and dancing. The intersection. You're a girl and you dance, so that's 15. How many students like to play sports? Well, everyone in here is a student. So if you look at the total number that play sports, that would be 23. How many girls don't like to play video games? Well, there are 30 girls total. 5 play video games. That must mean that there are 25 that don't play video games. Let's check this out. Here is a frequency table that's not all the way filled out. Let's see if we can figure this out. Horizontally, these three numbers should add together to get 27. So that means 0 plus 4 is 4. Well, what do we add to 4 to get to 27? Well, that would be 23. See if that works out this way. Is 23 plus 15, is that 38? It is, so that works. Here, 8 and 15 is 23. What would you add to 23 to get 24? That would be a 1. That works out vertically. 0 and 1 is 1. Here, 27 and 24, that is 51. 8 and 4 is 12. Is 1 plus 12 plus 38, 51. It is. Our table's done. What's the probability that you choose a person at random? So let me read the scenario. 15 and 30-year-old males were asked which of the following actors they like best as Batman, and the following results were found. So if you choose a person at random, a person that was surveyed, what's the chances that person prefers Adam West as Batman? Well, only one person chose Adam West. How many people were in this total survey? 51, so that's 1 out of 51. What's the probability that you choose a person at random and that person's 15 years old? Well, there are 27 15-year-olds. That's the number of favorable outcomes. There's a total of 51 people in this group, so it's 27 out of 51. What's the chances that the person you pick prefers Christian Bale? Well, there are 38 Christian Bale lovers out of 51, so it's 38 out of 51. What's the probability that the person you pick is 30 years old and, intersection, prefers George Clooney? So here's the George Clooney column. Here's the 30-year-old row. The intersection of that is 8. So 8 people prefer George Clooney if you're 30 years old out of a total of 51 people that were in this group. 15 years old and not Christian Bale. So here's 15-year-olds. Not Christian Bale would be here and here. The intersection of those, so that's the intersection is 0 and 4, which is 4, out of the total number of people in the survey is 51. All right, get even more complicated. Nothing is filled out in this table. 23 juniors and 31 seniors were asked which class they liked better between AP World History and AP Calculus. First of all, we got 23 juniors. So that's easy. Total juniors, 23. 31 seniors, that's easy. Total of 31 seniors. Something else that we know from this, that the total number of students has to be 54. I'm going to put in red something that we calculated on our own. 41 students picked AP Calculus. So that tells me that this AP Calculus has to add up to 41. And 11 juniors picked AP World History. Juniors picked AP World History. There were 11 of those. We put an 11 there. To fill out the rest of this table, 11 plus this number has to be 23. So that means this has got to be a 12. 12 plus this number has to be 41. That's going to make this 29. This number plus 41 is 54. It's going to make this 13. This number plus 29 is 31. That's going to make this 2. Let's just recheck. Yep. If you add across, you should get those numbers. You do, so we have been successful in filling out that table. All right, emphasizing the and again. And's the intersection of a row and a column. What's the probability that someone has a smartphone and an iPod? So here's iPod, here's a smartphone. So the intersection of that is 20, and that's out of a total of 50 people. No smartphone and no iPod. Well, the intersection of that would be 4, and the total people is 50, so the probability is 4 out of 50, or 8%. The probability of no smartphone and an iPod. No smartphone, iPod, there are 8 of those people out of a total of 50. The probability is 16%, or 8 out of 50. Or is the sum of a row and a column minus the intersection. And I'll explain why that's the case here in a second, but I think it's going to make some sense to you. So the probability of having a smartphone, it says it's the sum of the row and the column. So the smartphone probability is 38 out of 50. So it's the probability of having a smartphone plus probability of an iPod, and then we subtract the probability of the intersection of the smartphone and the iPod. It might not make sense at the moment, but I'm going to explain it to you. Let's just fill this out and then I'll explain it. The probability of having a smartphone is 38 out of 50. The probability of having an iPod is 28 out of 50. We have to subtract the intersection of a smartphone and an iPod, which is 20 out of 50. That's going to give us a grand total of 46 out of 50. Now let me explain a little bit. If you count the people that have a smartphone, it's 20 and 18. That's how we get 38. If you count the people that have an iPod, it's 20 and 8. That's how we get 28. Now what just happened? What happened is we counted this 20 twice. We counted it when we went this way, we counted it when we went this way. And that's why at the end we have to subtract the intersection, because we have counted it 2 times. Let's do another one of these, and I'll do it a little bit differently. Instead of writing it as 3 separate fractions, we'll write it as 1 fraction. So how many people have no smartphone? That's 12. How many have no iPod? That's 22. Then we subtract the intersection of no smartphone and no iPod. That's 4. And the denominator is 50 the whole time. So if you add those together, you're going to get 30 out of 50. Conditionals in two-way tables. We did conditionals yesterday. We didn't do it in table form, so today it's in table form. So given that someone has an iPod, that means we're only looking at this column. So our total for this is 28 without even reading what the rest of the question is. We're not looking at all 50 people. Given that someone has an iPod, what's the chances that person has a smartphone? Well, there are 20 people that have a smartphone under that category, so that's 20 out of 28. Reduce it if you want. I don't require it. What's the probability that you don't have a smartphone given that you have an iPod? So we're just in the iPod column. No smartphone is 8, so that's 8 out of 28. Given that you don't have a smartphone, no smartphone, so we're only looking at this row, which means the total here is 12. What's the probability that the person has an iPod? Well, there are 8 people that have an iPod out of 12. You can make that as a percent or a decimal if you want. You can reduce it or you can leave it like that. What's the chances, given that someone does not have a smartphone, still in this row, that they don't have an iPod? Well, that's 4 out of a total of 12. 1/3. All right, we got a few more. Determining independence in dependence. Now, this gets a little complicated, to be honest with you. But you're smart, so that's okay. There are 2 tests for independence. Test 1. If the probability of the intersection of A and B is equal to the probability of A times the probability of B, then they're independent. If the probability of A given B is equal to the probability of A, then they're independent. So let's check this out in practice. Determine if what's happening here is independent. We're using this as an example. So what's the probability that someone has an iPod and a smartphone? Well, it looks like that's 20 out of 50. Now, is that the same? We're going to figure this out. Is that the same, we're on this first test, as the probability of having an iPod? That's 28 people have an iPod out of 50, times the probability that they have a smartphone. That's smartphone. That's 38 out of 50. Are these 2 fractions equal? 20 divided by 50 is 0.40. 28 times 38 is 1,064 over 2,500. And and that is 0.43. These numbers are not equal, therefore these are dependent events. They are not independent. Not independent, because that wasn't true. Let's check this out. If this is true, then it's independent. This is the second test, which it obviously isn't going to be because I already figured out it wasn't, but let's just show you how this works. What's the probability that someone has an iPod given that they have a smartphone? So there are 38 people that have a smartphone. Of those, the ones that have an iPod are 20, so that's 20 out of 38. What's the probability that someone just has an iPod? Well, that's 28 out of 50. This is 0.52 and 0.56. Those are not equal. These are not independent. That's how you do those tests. Almost finished. We have a two-way relative frequency table. So here's how this works. So here's the two-way frequency table that we've been using. If you take 12 and divide it by 50, you're going to get 24%. If you take 7 and divide it by 50, you get 14%. 9 divided by 50 is 18%. They've already taken and they put the percentages in as a decimal instead of the raw numbers. So if you're asked, what's the probability that the person's a male? Well, 56% of the people here are males. Versus us doing 28 over 50, which is also 56. What's the percent that are female? 44%. What's the probability that you pull a red at random? Well, 40% are red. What's the probability that you choose a yellow at random? 6% are yellow. What's the probability that you pick a male that prefers red? So a red male is 24%. I don't think it's Native American. I just think that they like red. These are people that like colors. No blue people. No green people. Probability it's a male and red. You gotta be careful here. Probability that's a male. Probability that's a red. So we would say that it is 0.56, that's the total males, plus 0.40, that's the total reds. We subtract the intersection because we counted it twice. And that gives us 0.72. That concludes the notes. Hope you enjoyed it, y'all.